Yeah, but it's Dark Guardsman. We're back with part 4 of how to make a item-based battery storage block, whatever it's called. Now we're probably going to be recording this at a pretty odd time and see how far we can get in here before we have to stop and return with this tomorrow. So last couple episodes we went ahead and implemented the internal logic required to check for the capabilities, to return the capabilities, to get our energy storage, get our inventory, and to wrap our inventory as an energy storage for use and accessing with other machines and tiles and everything else. So that's been done, and we've actually got the code implemented here. Nothing's been tested at the moment, so we still need to go and work forward in order to be able to get the testing and making sure everything is actually done. For this episode, what we're going to do is go ahead and start building interaction to actually get that testing to work. Now the first thing we're going to do is we're just going to build some really simple on right click interaction just to add a battery to the inventory and take a battery back out. Now we're going to do this very simply. When we go to stick a battery in, it's going to go from the 0 slot all the way to the end and try to insert. When we go to take a battery out, it's going to go from the last slot back to the first slot and try to find the last battery in there and pull it out. Now we're going to do this with the basically on interaction event. Let's see if I can find it here. On block activated. Really simple right click event, return true if you actually interact, false if you don't interact, gives you access to the player, the hand that was clicked with, the face that was clicked, and the exact coordinate on that face of what was actually hit. It also gives you the state, position, and world, so that way you know exactly what's clicked. We really don't care about any of this except for maybe getting the tile entity with these first two. So we're going to go ahead and implement the interaction here. Go ahead and implement that method. Add override to make sure that we can tell when it changes. It'll never change probably anytime soon. And then we're going to do some simple logic here. So we're going to do world in doesn't equal null, or not doesn't equal null, we want to do is remote. I'm thinking a completely different terminology and have yet to script this video. So we just want to do a really quick check to make sure that we do all of our logic server side, and we're going to return true always because we always want to grab interaction for this block. Actually, on that note, let's do a little bit better. Now, I was going to do any interaction, then I realized, you know, we might want to chain batteries together in order to build a really nice battery bank or something. So let's go ahead and actually figure out what the player's holding. We can do this very simply, getting held stack. So this would be player in dot get held item, and you just pass in the hand. I really wish they would just pass this in for us, but I mean, you may have interaction, doesn't care what you actually have in your hand. We just want to make sure that stack isn't empty. It will turn empty if it's basically you have nothing in your hand, and we just want to return false. What we can do here later is we have an else statement, and we can go to do open GUI. So when we get the GUI open, we can do that, and we just return false any other time, say we have a block in our hand. So that'll work very well. And then after we figure out that the hand is not empty, we want to check to see what we actually do have held. And in this case, we want to go held item dot has capability capability energy dot energy item, and then we want to return null for that. And this will make sure that we only insert actual battery items and nothing else. And that should work. And then what we want to do is just simply find a way to insert into the system and find a way to pull out of the system. We're going to do this with the tile entity. We're going to go ahead and get the tile entity up here just to kind of keep things nice and clean. The reality is you could put this somewhere down here. Usually you can probably get away with it putting down here if that way you're lazy in it. It doesn't really matter. The performance impact is so low that it's okay. So world in get tile entity, pass in the pause. You could do some instance of checks and null checks up here if you want. I'm going to do them down here, and that should work. So we got make sure remote, and then we're going to go if tile entity or tile entity instance of tile entity battery. So we make sure that we are our battery. You always do want to make sure you do an instance of check. You never want to assume that you always will have a tile entity. One, the tile entity could not have been added for some freak accident. Two, you could have had some dirty data that would have ended up putting on the wrong tile entity. This can happen in cases where you have automation placing blocks and it didn't clean up the previous tile, and then the world returned the wrong tile to you. It's very, very rare, specifically in newer versions. That problem is almost non-existent, but it's still a problem that you need to worry about. So you would make sure you actually do that. So we got our check to make sure it's remote, our check for this, and you can kind of clean this code up. For those who are more experienced, you'll know that I could definitely make this code look a lot nicer and everything else. It doesn't really matter. So we know we get our battery, and now we want to pretty much tile entity.get inventory, and then we just want to basically have a way to add an item. And yeah, we're just going to do held item, and what we'll do is we'll have that method return we basically set the held item, and then we'll do player.set or get inventory. Actually, I think it's just flat inventory. Inventory, yep, there it is. Set inventory slot content. We need to get the slot, which I believe we can do player.get slot or get inventory. Get. There should actually be a way to do this. I wonder if there actually is even a method for this anymore. So you can get the held item. And let's actually just go to this one, because this one should tell us exactly. So get stock for slot, and then yeah, you would do main hand or offhand. Not the greatest way to do that. I guess what we can do is just call this method. Oh, actually no, we want to... I believe if we actually... Because this is using an equipment slot system, so I think we're just gonna have to make ourselves a little if method here. So let's just actually build up a useful method. We're gonna call this transfer into inventory, and what we'll do is we'll go ahead and we'll add the player, the hand, and the held item, and this will do our work for us, because then we don't even have to return anything. We just go transfer and it'll do the work for us. Then we can create this method, and we'll go ahead and create this in external inventory. So get player, hand, held item, and this way we can actually create a method in here for actually adding it, and then we can make sure that the player gets the right data set. And how this will work will be player.inventory.set inventory slot content. We want our slot here, and then we're going to basically whatever the held stack is left, if we're going to transfer it. And main item, that's an enum value, and this should have, yeah, slot index. So we basically want to get the slot index. Here we go. And this should, in theory, yeah, it's just a void method, so we don't need to do any kind of return here. Not that we can return anyways. And we'll do that, and we'll copy this down here, and we'll just make sure we set it to offhand. This is probably not the cleanest solution for this, but I have yet to dig into how the offhand system works down to a deeper level. So we've got this. Now the next thing we want to do is public void add item to, yeah, we'll do add item to inventory. We'll just make a little longer method for this, and we just want to basically pass in the stack, because we don't really care where the stack comes from. We just want to have that stack, and then we're going to return whatever's left over the stack. Item stack, there we go. And we pretty much just want to go through our inventory. So we're going to want to find empty slots. I believe I have a method for this already. I also have methods for inserting items too. These are pretty much copied from the item handler system. So there should be a method somewhere in one of these parent classes that allows me to find all of the slots that are empty and then iterate over said slots. Yeah, here, get filled slots, get empty slots, get slots with space. So what this works is basically if empty slots are always going to be empty, get filled slots are always going to be, well, full, and then get slots with space are going to return any slot that has space left. So this is what we actually do want, and it more or less how this works is it's just going to iterate over and pretty much grab slots with space. I probably need to come back in here and make a much more beautiful method for this, especially with the Java 8 features, where we could make an iterator call and then have that insert stuff into it. Right now we're just going to do this the ugly way, and I'll come in and optimize it later. So and does this actually give me back the slot? Yes, it gives me back slots. Int slot, get slots with, or yeah, get slots with space. There's filled space. I just copy the method, save myself all the trouble. And then we just want to loop through, and we want to get the item stack in it. So item stack, stack in slot equals get stack in slot slot. If stack in slot is empty, and then we just want to add the item. Set inventory slot content slot held stack. We probably should do some min maxes in here just to make sure. I'll even note for this later to do. Make sure max size is respected. This will not be a huge issue because we don't have an inventory at the moment that actually has slot size limits on it. And then the other part for this would be, and I really don't think we're going to run into a situation where we can merge two batteries, but of course this code is meant for a prefab, so I got to make sure it actually does work. We think we can do inventory, utility, stacks match. Basically, we're going to go with like the held stack the same as the slot stack. We don't care about the actual stack size. And there actually should be methods for this. Actually, what I think we can do is we can just call this up here. Yeah, I think it's what we're actually going to do, because what I think this does up here, this does everything we need it to do. So what we're going to do is just loop through until the stack is empty. And this should return... Yeah, it should return stack empty at some point, so... Yeah, let's do that. That's a probably smarter idea than what I was doing. Then we're just going to return held stack, and then how this will work is we're just going to do held stack equals insert slot held stack, and then true because we actually want to insert it. We aren't doing a false here. And then if held stack basically is empty, we should never have a null state, but we also want to do held stack dot get count is less than equal to 0, just in case something happened where one of these returns up here. When it went to go set it, somehow returned a empty or something to do that, and we just return item stack empty at this point. So if we basically consume the whole item, we use it. We'll make a similar method here for pulling out the first available item. We'll get to that. We're going to do the transfer in first. So that should transfer in inventory, and this should add. And what we want to do is add to inventory held stack, and make sure held stack equals. To be honest, we don't really need to do the return here because how Java works, if it's an object, if you edit the object in the parameter, it'll edit the object in the parameter up here too, because you passed it in. So it's going to edit whatever that variable is that's passed in. I'm doing it this way just because I like the way that code looks. And it makes it very clear that we are indeed editing the data. And we can make that even clearer by going add stack to inventory, stack is consumed. And then this is update player. And we also want to make sure that player.inventory.send, actually I think it's container, inventory container.detect, yeah, there we go. This will actually send a packet, so this is what this actually does. Send packet to update player with new inventory. It's very important to actually do this, because if you don't do this, but you only did this part, I don't know if they actually changed it, they may have. No, I don't think they've actually changed anything in here to make sure it gets updated. So you did do this. This is something that I've always done in 1.7 to make sure the player's inventory does get updated. So we transfer item into the inventory, we add it to inventory. So we get two new methods in there, really nice. We can use it in future videos. And then now we have ability that if we right click, we should actually see items added to that. And what we're going to do along with this is we're going to add a check that held stack dot get item equals items.stick, and what we're going to do with that is we're going to use that as a really cool debug tool to quickly just tell us how many batteries we have in there, so we can go ahead and get some code tested in this video and not have to wait till the next video to actually do this. To do the information really quick, we just want to go player in, send message, new chat, or new text component. They've always changed these, so I'm always confused on what the naming is for. Batteries. And then what we're going to do is we're just going to call tileInventory.getInventory. Well, let's go ahead and move this up to... Yeah, we'll move it up to here. So we're going to return false if we don't actually have a check here. I have an extra bracket somewhere. I guess I don't have an extra bracket? No, there's definitely a missing bracket here, because that shouldn't be... Yeah, I think what happened is it shifted my brackets all the way over. So this actually should be here. This should be here. There we go. Fun part about copying and moving if statements, if you don't do it correctly, it'll mess up your logic. So that looks good, and then that way I can call inventory check on this. So get inventory, and then we want to get not the size of the inventory. We want to get slots. We're gonna get slots that are empty, and then we're gonna minus that by the number of slots in total. It's not the best way to do this, and we'll move this up to a variable just to make this a little easier to read. And slots and use. And this is like a backwards way to do this. In reality, what we'll do is we can make a method for this, but since this is just meant for debug, so we actually can check if our code's working. Actually, that's not what we want to do. Slots empty minus slots total. Get slots, or gets, oh, it's, yeah, get inventory, and then get size inventory. Or get slots in this case. And that should give me the total number. And we need to do size on this one as well. Size. So that should tell me how many slots we currently have in use. And we won't know exactly what's in there, although I'll show you how to debug that in a second. So let's go ahead and actually get this running. And check to see if our block is placeable, if it works, and if we can interact with it. And then the next episode we'll work on the GUI, and we'll finish off the interaction. Taking a bit longer than expected to make this, but then again, we are making a non-vanilla battery. If we were doing a vanilla battery, I probably could have finished this in a short 20-minute episode. Because in that regard, we would already been done, because all you had to do is add the capability, and then you could add inventory if you really did want to charge batteries, which would be pretty simple. We might do another video on that later, as I do need to make my own battery cubes for another mod. Always the main hurdle in mod development is waiting for Minecraft to actually take the time to load. It's always the assets that take the longest time too. The logical stuff runs pretty quick. Registering blocks and items is pretty fast. Recipes are pretty fast. Entities are fast. Trying to do all those model baking is what really does tank Minecraft down. There's probably ways to optimize it. All of them would require editing base code, which is something Minecraft should definitely do. Anyways, let's go ahead and wait for Minecraft to stop lagging as it loads. I don't know what's with my environment lately, it's been really slow. So here is our battery box. Now, because we haven't set up any of the renders for it, it's going to look like this little cube. It is placeable, so we actually do have a thing here. Unfortunately, no textures, no nothing, so we're going to get effectively squat. So we're not going to have anything there. What we should see happen though is if I pull up a stick, and we'll go ahead and find a stick here, if I remember what tab it is on. Still we get used to the fact they merged a couple tabs. So we know there's 0 batteries in there, so we can insert, and that unfortunately killed off my stick for some reason. This is the beauty of working with code, is that somehow we oh yeah, we forgot to register our talented too. That's going to make a huge problem right there. That's a really simple issue to fix. We'll do that in the next episode, though. But why did it eat my stick, though? So I'm going to show you how to debug issues like this. So one, let's get another stick out. And right-click. Okay, so that's going to trigger this debug line. Then we're going to go into the actual method. And we're going to see what the method does. So we know we have an inventory. It's going to actually return an inventory. And we're just going to keep doing that, and it'll return, it's going to grab all the methods. So we have our health stack, and our health stack that it actually returns is battery, so we know it's got the right stack then. So it's got the hand position, which looks correct. So now we want to go and add to inventory. It's going to find slots with space. In theory, this should have inserted something. So it's going to find the first slot, it's going to insert. And then what should have happened with this is we should have saw an item inserted in there. Oh, we did false, so we're not actually going to see anything. I forgot this is simulate true, not simulate false. It's really complicated. It makes it even more confusing with a lot of my methods. I have do action as the thing, so do action as true, which is the complete opposite from simulate. So that's going to mess up there. But at least we can confirm that it kind of did what we expected. We can look at the variables here. So yeah, that's going to return tile error because that's what empty stack actually is equivalent to. And then this should update the player's inventory with the held stack. Main hand. Someone tells me I've got the slot index wrong. Slot index is the second variable, so it's got a really strange... But then you see these have got like 0, 1, 0, 1, 2, 3. I think we got the right index at least, so that's good. So let's go down to the next line on this. Detect some changes, so the code looks appropriate. But I'm going to assume it killed our stick again. So we're going to hit play as soon as it decides what it's doing. And we're going to go back in. Yeah, our stick is gone. So we definitely are running with the wrong item. I think it has to do with we're grabbing this slot index. And how the slot index works is it should hover over one of the slots on the bar. So we actually do have the wrong index. So let's go ahead and fix this. So we don't want the slot index, so we're going to set slot content. We have to figure out some way to get the slot. And we're going to have to do this by just really reverse engineering really quick how Minecraft itself does it. So we get stack. Is there like maybe set stack? Set item stack to slot. Yes, there actually is a method for this. And it gets equipment slot in stack. So main hand, current item, offhand is always 0. Okay, so we're getting there. So we know there's a method for it already, so we don't even have to worry about this. We just have to do something like this. And that'll work, because that's what we effectively wanted to do in the first place. This is the good part about actually taking time to read the Minecraft code, because Minecraft code holds most of the answers for the basic stuff. Anything advanced, like doing wire networks and batteries, that's something you're just going to have to like learn from other mods or figure out on your own. But if you sit here and you reverse engineer code, and you go through and you follow it, which Control B is how I'm jumping around, you can go through here and you can look at what this is doing, and you can hear the play equip sounds and everything else, and you can see exactly how the code would behave, how you can get around it. You can understand how the slots are set up. Apparently 0 is always the offhand slot, which doesn't make sense, considering the fact that the offhand would be, I believe that's not T to switch items. There is a button that switches items, and I've completely forgot how it works. No surprise. Oh, it's F. There we go. So the offhand is always going to be that offhand slot. And I believe if I click with the offhand, it will actually trigger with the offhand, I believe. Always a good idea to test your functionality too with weird things. So yeah, we got the offhand right there. And we should be able to follow this code all the way through, which I'm not going to actually do. I'm going to hit play and just see if it works. So we still didn't get any kind of update going on. It's not eating my stick at least. That's a good sign. And however, it's not eating the item either. So, what I think maybe we want to do is look at this method again. Does this return an item stack? No, it does not return an item stack. Return held stack. Held stack. Held stack equals this. Okay, so we are definitely going to have to follow this through then, in order to figure out what's wrong. Okay. Hey, our inventory drop code works, so that's good. Okay, so we right-clicked, Add stacked inventory. And we should see insert into. It just should go through, and it should find an empty slot, so it's going to go through every slot one at a time. Gotta figure out we have a capacity one. This is where we have the capacity check. It's something I was going to implement the other function if we did it. It's going to copy it. It's going to reduce the count by the insert, which are, yeah, at this point we just turned into an empty item. Which then we set to an empty item anyways, so apparently we don't even need that anymore. If it's not a simulation function, we copy it again. So we have stack. Stack is our original insert. Set the count on the copy. That's cool. Then we insert it, which looks good. That part looks good. Then we're returning that empty stack, so that's good. So that code looks perfectly fine. So our current health stack is battery. If we go down the next line, our held item is air, so that's nice. Then we're just going to return empty anyways, so that's good. So our health stack is air, that's good. Let's go into the vanilla method and make sure the vanilla method's working. You know what I forgot to do? There's this really cool trick called alt reload, and we forgot a hotspot. Yeah, one class reloaded. So let me hit play, because I'm going to say the code actually does work, and we just followed it through nothing. So there we go. Yep, consume battery. There we go, and if we get our stick out, we have 5 batteries in there. Now theoretically this would take power. We have no checks for it, so we'll get to that in the next video. But we know for sure that we can now stick batteries in this inventory and everything else. So I'll see you guys later with another video.